Welcome to the demo of virtual prototype start package from CircuitSutra. In this demo, we will demonstrate the package for Ethernet. Before we start the demo, let's have a quick look at the content of this package. VP-QSP Ethernet. It has a TLM Ethernet protocol, which defines transaction level interface for communicating between two Ethernet modules. It has a convenience socket, TLM Ethernet MAC socket, which encapsulates complex Ethernet MAC protocol inside it, so that if anyone wants to develop Ethernet controller model, no need to worry about implementing this complex protocol. They can create an instance of this socket and call the APIs. It has a model of host PC Ethernet controller, which encapsulates the network interface on the host PC, so that the VP can access the network of the host computer. It also comes with a sample model SMC91C11 Ethernet controller. In order to demonstrate this, we will be using CST board, which is a virtual prototype of sample SoC based on the ARM Cortex-A15 CPU, which is capable of booting Linux, and it can be used for embedded software development. The models present in the CST board are developed using CircuitSutra modeling library and VP-QSP. This is the high-level block diagram of CST board. It has a model of ARM CPU Cortex-A15, which is based on the QEMU. We have extracted the CPU core part from the QEMU and developed a systemc TLM 2.0 wrapper on top of that, so that it can be used in systemc based virtual platform. It has a TLM 2.0 bus and models of several peripherals. CST board has models of minimum peripherals like TLM memory, interrupt controller, and timer. Apart from that, it also has models from various quick start package, but in today's demo we will focus on Ethernet controller SMC91C11 and host PC Ethernet controller. Before starting the demo, we will have a quick look at the source code of CST board. This is the header file of CST board. It has instance of all the peripherals in the CST board and interface for communicating between the CPU model. This is the instance of SMC91C11 Ethernet controller, and this is the instance of host PC Ethernet model. In .cpp file, you can see the SMC is registered on the TLM 2.0 bus in this address space, so that whatever TLM2 transaction comes to this address space will be handled by the SMC Ethernet controller. And also the MAC socket of the SMC Ethernet controller is binded to the MAC socket of the host PC Ethernet model. CST release folder is where we have the setup for running the CST board. The steps for running the CST board is given in the doc quickdemo.txt. The first step is setting the environment. For this, we are providing a script cstsetup.sh for Linux. In this, we have to set the two variables. The one is cstrel. Here we have to provide the path of the CST release folder, so that the CST board can pick the right DLLs from this location. And the next is CST config file. Here we have to provide the path of the configuration file, that is config-file.lua, where we configure the parameters for various models in the CST board. For example, for SD memory, we are configuring the SD memory model for 4 MB, and we are giving the file name as SD_memory. The next step is running the CST board VP. For this, we have to run the executable cstboard.exe, and we have to provide the path of the Z image and the bootloader to this executable. And the steps for VP-QSP Ethernet is given here, and some prerequisites has to be done in order to make the VP-QSP Ethernet work, which is given in the doc readme VP-QSP Ethernet.txt. In order to make the VP-QSP Ethernet demo work, we have to create a tap model on the host PC, so that the VP can access the network interface of the host computer. CST tap is nothing but a software only interface, which will be present on the kernel of the host PC, so that the VP can forward the packets to this tap, and the tap will forward the packets to the network interface on the host computer. And we are providing a script create a tab.sh, which will install the CST tap on the host computer. I have already installed this tab. You have to run the command sh create.tab.sh, and you have to provide the interface name of the network card on your host computer from the location, dependency package, Ethernet, and Linux. Now I am running the CST board. and I'm providing the path of Z image and bootloader. So this is a CST terminal model. So here you can see the boot message of Linux kernel being redirected to this terminal. You can see here the list of peripherals identified by the kernel on the CST board, MMC, SD card, etc. I am logging into root. We'll follow the steps of VP-QSP Ethernet demo. First, we need to configure the network card interface on the VP. Here I am providing the IP address 10.0.0.2 because our tap has been configured for 10.0.0.1, so that we can provide the IP address for VP from ranging between anywhere from 10.0.0.2 to 10.0.0.255. So I'm running this step. So you can confirm through ifconfig command. You can see here it is configured for IP address 10.0.0.2 and net mask 255.255.255.0, and we have to provide the IP address of the tap as gateway here, so the packets can be forwarded to the tap, and from tap it will be forwarded to the network interface on the host computer. So you can confirm through root command. So here you can see here default gateway has been set. So now we must be able to ping to the localhost, that is the CST tab. So you can see here 2 packets received successfully. So now we will try to ping some web address, that is google.com. This is the IP address for google.com, now which I am trying to ping. So now we are able to ping to the google.com as well. Now I will try to download some web page. I am providing the IP address of the google.com. So it must download the index file of the google.com. So you can see here index.html file has been downloaded. You can view the contents through cat command. This completes the demo for VP-QSP Ethernet. All the models in the CST board, they were actually developed using the CircuitSutra modeling library, which is a collection of convenience class and utilities to use the model development activities. It has a model generator utility so that you can specify the interface in some Excel sheet and it will generate the model and test bench for you. The primary benefit of CSTML is that whatever model you develop using CSTML, it will automatically become tool independent so that it can be easily integrated with any virtual platform tool. Another benefit of CSTML is that it automatically becomes platform independent so that the models will support on Linux 32, Linux 64, Windows 32 and Windows 64. The models were using virtual prototype quick start package. It is a collection of a library of basic models and modeling infrastructure. It has TLM protocols and convenience socket for popular chip interface and backend modeling infrastructure to access the host interface. So in our case we are using host bridge Ethernet model, which is nothing but the backend model which was accessing the network interface of the host computer. Similarly, we have backend models for accessing the USB interface, MMC card, SD card, etc. Whatever model developed using CircuitSutra modeling library and VP-QSP will reduce the development efforts up to 80% for complete SoC or electronic system. This completes today's demonstration. Thank you.